Hello guys, how are you doing? Today we are going to learn about the Mosfet. And first of all, you need to understand what are the Mosfet or what is the Mosfet. So a Mosfet, that's not a full name for that component. That's in fact that's a short form. We call it Mosfet or Mosfet. So these are the special kind of transistors which switches the power, right? Yes. Sometimes they call it power switches. Yes. And this MOSFET, these are short form for the word metallic oxide semiconductor field effect transistor, right? So this is metallic oxide semiconductor field effect transistor, right? Yes, field effect transistor, field effect transistor. So in short, these are special kind of transistors which are responsible for power switches, right? Yes, this component is in this format. So you find a component, it has 4 pins from each side. So in total, there are 8 pins inside the MOSFET. So you have pin number 1, you have pin number 2, pin number 3, and pin number 4, right? Then here, you have the upper part of that component, and this entire pin here, this whole pin here, this pin number 1, pin number 2, pin number 3, and pin number 4, all of them are connected together, right? Then at the other side of this, we also have the 4 pins. However, at this side, you will have 3 pins which are connected together. All of these pins are connected together. So that this other pin here and this other pin. So all of these are connected together. That's why I joined them together. And we have an independent pin here. So this pin is independent. And I believe you can see, guys, I have a cap here in between this side and this side and this side. So the 4 pins, you have these 4 pins which are connected together. You have 3 pins connected together, an independent pin here, right? Yes. And this pin, we call it gate. So this is the gate, and we represent it with letter G. These 3 pins which are connected together here, we call it source. So this is source, and then these other pins which are all connected together, the 4 of them, we call it drain, right? Yes, and this one we represent with letter B. This one we represent it with letter S. So in a MOSFET, we have 3 sides. You have the gate, we have the source, and we have what? The drain. So each of these 4 pins, it serves a purpose, right? Yes. So when the voltage reaches this side, there is a border, there's a cap between this side and the other side. So once the voltage is at this particular side of this MOSFET, there is an IC which is responsible for switching that power from this side to the other side, depending on how much voltage is at the other side, right? Yes. So at this side, we have a dot here which shows us the direction. So since we have this dot here, so it means at the far end, at this corner, we will be having the gate. So in case you have another MOSFET here, so let's assume you have another MOSFET here with still 4 pins at this side. However, but in the case of this MOSFET, instead of having the dot at this side, we'll have a dot at this other side. So meaning we will have a MOSFET of this kind. We'll have a MOSFET of this kind. You see, and the gate we will have it here. So here we'll be having the gate. Here we'll have the source. And here we have the drain. Alright, guys. Yes, I believe you are getting it. So we have two. So meaning what? We have 2 types of MOSFET. We have this one and this one. So the 2 types of MOSFET I'm trying to tell you, we have what's called P-channel MOSFET and N-channel MOSFET. What is the difference between the two? So this one, we call this one N-channel MOSFET. N-channel MOSFET. And this one, we call it P-channel MOSFET. P-channel MOSFET. Right? Okay. Anyway, there is no alarm for. I don't mean to scare you with this type of channels, however, but I want you to know the functionality, because the functionality of these MOSFETs are the same, except that you can't replace the N-channel MOSFET with a P-channel MOSFET, right? Yes. So I want to show you how do you know this MOSFET is faulty or it's working. Since we said we have the drain, we have the source, and we have the gate, for you to know which MOSFET is working, the first thing you have to know that there is no connection between the drain and the source, and still we don't have the connection between the source and the gate, right guys? Yes. Still we don't have the connection between the drain and the gate. So in case you have a scenario where you can test the continuity, or where you can feel like this drain is connected to the source, it means that component is faulty, right? Yes. So you need to know that the drain is not connected to the source, and still not connected to the gate, right? Yes. So how do you test for a short? How do you test for a short in a MOSFET? Yes, here with me I have a meter, so I believe you know how to use a digital multimeter. So this is my meter, guys. So my meter is off. You can see the pointer is pointing at the off point. So what you need to do is to turn on your meter and make sure your pointer points at the continuity mode. This is called continuity mode. So I believe you can see it. So this one. So this is the continuity mode. At this point, this is the point where we can test the continuation of a particular path, or at that calibration, it will show us which point is connected to what point, right? Yes. So since here we have a MOSFET, so you can see when I put the two probes together, I have a reading of 0.0. So it means these points are connected to each other, right? Yes. So for the MOSFET, when I want to test for faulty MOSFET, I'll put my one probe to the drain, then another probe to one of the pins here at this side of the source, right? Yes. Because I know each one of these are connected together, the three of them are connected, so I can place my probe at either side. The same case with this one. I can put my probe at the drain and one pin of the source. When there is no pipping, or there is no sign, there is no reading for continuation, it means the drain and the source are not connected together, right? Yes. Same case with the gate. I put my probe into the drain, then connect it to the source, the gate. In case there is pipping, so it means the drain is shorted to gate. It means that component is faulty. In case there is no continuation, there is no continuity or no pipping, it means those points are not connected. So it means that component is good. Same case with the gate and source. Still I can put my probe into the source and in the gate. Right guys? So let's do it practically. So here with me I have a motherboard here. So this motherboard, sorry. So here with me I have a motherboard. This I believe this is a Lenovo motherboard. With this motherboard, I have a MOSFET here. So this component is the MOSFET. So this is the MOSFET, and here I have a mark. This corner, this particular corner of this MOSFET is a mark. So meaning here I have a dot at this corner. So for me to test for faultiness of this MOSFET, so first thing I need to make sure my meter is in continuity mode. Let me put it here, guys, so that you can see it together. So I need to make sure my meter is in continuity mode, and that is it. It is in continuity mode. Then my other probe, I should place it at one of these pins. You can see if I have a dot here, so meaning pin number 1, 2, 3, from that particular area where there's a dot. You guys, because I draw it here, so I have a dot at this particular corner. So meaning this pin 1, 2, 3, all of those from where there's a dot are connected together. So I can place my probe at either of these three. Then the far end, the last pin is the gate. So meaning that gate is independent. So let's try to see, guys. So yeah, so from this particular point, 1, 2, 3. So these points, so those are the source. Then these points, these pins here, the four of them, 1, 2, 3, 4. These are the drain. You see, guys. So when I press it this way, I'm not hearing any beeping, or I'm not seeing any readings which shows there is a short. I can interchange the probes. When I interchange the probes, you see there are some resistance, that is 0.503 ohms. So meaning that point is correct. There is no short. The source and the drain are not connected. Same case, I can test with the gate to the drain. Still, I don't have a problem. Even if I interchange the probes, the gate, the drain. Right, guys? Yes. What about the source and the gate? The source and the gate, nothing. Even if you interchange the probes, the source and the gate, you see the resistance? Yes. So meaning that component is good. So how do you know these pins are connected together? Let's test it this way, guys. So I have the probes, so I can place the probe at either point. Okay, let's start from here. You see these first three are connected together. So I have this pin number 1 and number 2. You can hear. So it means those points are connected. What about the number 3? Still connected because that's pin number 3. What about number 4? No peeping, right? And no continuity. So it means this the fourth pin is not connected to it. First three, 1, 2, 3. What about the other pins? At this particular side, you have pin this far end pin. You can hear. Yes. So these four pins are connected together. So guys, I believe you have understood how to test for a short in a Mosfet as CCS like that, right, guys? Yes. So I believe by now you can test whether there is a short in a Mosfet. Now we are talking about the Mosfets alone. So in our next video, we shall be talking about components, that is ICs, capacitors, the diodes, and any other component we feel like we should discuss. So guys, thank you so much for being patient with me, and see you in the next video. Please subscribe to this channel and share with your friends. Goodbye. Have a good day.